Hello, my name is Shivam Pandey, and today we will be discussing a new topic in geotechnical engineering, that is classification of soils. So, let us begin with this topic. Classification of soils. First of all, we have studied the different aspects like what, the three phases of the soil and how it is classified in terms of different sieve sizes or different particle sizes. So, that is the basic understanding which we have got in terms of what index properties, in terms of what void ratio, specific gravity and different other things. So, the major thing that is required is there are innumerous number of soils. There are innumerous number of soils which are present in different areas, in different parts of the country, as we have already known that India is a diverse country in terms of the soil present. So, each and every soil behaves in a particular way, but we can classify the soils into certain types, into certain groups, and these groups should have what? Should have similar characteristics. So, let us see here this arrangement of soils into different groups such that the soils in a particular group have a similar behavior. This is the important thing. What we are studying about, what similar behavior, because we cannot study each and every soil. It is very much difficult for us to study each and every soil and to classify, and we have to classify that soil into a group so that it is easier to analyze the characteristics, because for a single soil, for a very much single soil, we cannot say that this soil is of this nature and the same group characteristic we can define to another soil also. So, it is more convenient to study the behavior of the soils than that of the individuals. It is more convenient to study the behavior of the group. So, there are many classification systems that are in use, and in particular what is the most common thing whenever we define a classification system? What is there? We have to classify a system and we have to prepare a system wherein it is simple to understand for each and every person. It should be having a limited number of groups, not having too many groups and then classifying it accordingly in subdivisions and all. So, the basic requirements of a soil classification system is that it should have a limited number of groups and it should be simple and easy to understand. So, now we will be moving on to how the classification system has been made and what are the different types of classification system. So, let us continue further. So, the different soil classifications in use are, first is the AKtU system, next is unified system, third is the Indian standard system and textural classification system. So, the very first one, American Association of State Highway and Transport Official System, that is AKtU. Unified soil classification system, that is the basic one which was developed by Casagrande in 19th century, in 20th century, and this was the basis on which our Indian standard soil classification system, the third topic which we will be studying, the third point which is given here, that is the basis. Unified soil system is the basis on which Indian standard soil system will be derived or where it has been taken from. Then the next one is according to the texture. We classify the soil according to the texture, how it feels. So, that is the textural classification system. So, basically there are four classification systems in use mostly, and in this module and in this topic we will be covering Indian standard soil classification system which is in use in India, and the unified soil classification system from which our Indian standard classification system has been derived. And we will also look upon the unified soil classification system, then we will move to the numerical portion of this. So, moving on to the next topic, next thing, the very first thing, that is unified soil classification system. That is the difference. I would talk about the difference between unified and Indian standard. So, understand one thing, that unified is a basis and Indian standard soil classification system has been derived from the unified soil classification system. So, the very basic thing we need to understand is where is the difference. So, it first of all I am telling you this, that the basic difference, very basic difference lies in the liquid limit of the soil. So, we will be first of all studying this Indian standard soil classification system, and then moving on to unified soil classification system, and what is the basic difference between the two. Okay, so when we are discussing this topic, Indian standard soil classification system, we will be first of all seeing how, and like if we are classifying as a soil, then what is the name which we can give to the soil. That is, let us say this as you are seeing on the screen, that G means what? Gravel. If it is sand, we will be going for S, then silt, for silt we will be going for M, then clay prefix C is used, for organic soil O, and then for peat we will be using PT. Okay, one thing more here, that these are the prefixes, and there are something called as suffixes which will be used on later after the prefix, which will be used after the prefix. So, for a well graded soil it will be W, for poorly graded it will be P, for silty soil it will be M, for clay it will be C, and for different liquid limits, according to the liquid limits we have classified the soil into what? Into a low medium, low compressible, intermediate compressible and high compressible. So, these are the things which we will be studying. If the liquid limit is between 35 and 40, it is intermediate, 35 and 50 it is intermediate, it is less than 35 it is low, then if it is greater than 50 it will be highly compressible soil. So, one thing you should understand, that where we have to use this prefix and suffix, how we will be classifying the soil, and then how we will be naming naming the soil. So, and one thing more here, this system has been adopted by a Bureau of Indian Standards in many respects similar to the unified soil classification system, as I have been telling you since the very first slide here. Okay, then what is the Indian standard soil classification system based on? When we will be discussing this system, we will be seeing what? First of all, we will be seeing the particle size, that is, we have already discussed in sieve analysis that there are certain sieves like this. If we are saying there are certain sieves and it is 4.75 mm, it is 4.75 mm here, and there is 75 micron sieve, then somewhat lower sieves are there. So, if something is retained on this sieve, so it is what? It is percentage retained. If the soil passes on, to the lower, so it is having a size smaller than what? Smaller than 4.75 mm, because it is passing from this sieve, from this very sieve. So, it will be retained on here, or it may happen that if the particle size is smaller than 75 microns, so it will pass down to much lower one. So, we will be discussing how this particle sizes, how the sieve sizes will be like we will be classifying it accordingly, how will each and every particle size will affect the composition of the soil. Second is the plasticity characteristics. So, in this plasticity one, we will be discussing there are two things, that is IP and with respect to WL. These two things will be there, IP and WL, and this will be denoted by the plasticity chart. Then third is the compressibility of soil. How much compressible is soil? As we all know, organic soil is highly compressible. So is the different soil which are fine grained also. So, we will see which one soil is the fine grained or which one is the organic soil based upon the compressibility. So, we will be looking on further how these particle size composition, plasticity characteristics and compressibility of soil is affecting the different types of soil and how do we classify it. So, the very first thing, see here, coarse grained soil. If you are talking about coarse grained soil, it is when 50% or more of soil is retained on 75 micron IS sieve. If you are talking about fine grained soil, it is when 50% or more of soil passes 75 micron IS sieve. So, the first thing is what? It is retained on a sieve, it is retained on 75 micron IS sieve, and when we are talking about fine grained soil, it is passing the 75 micron IS sieve. Similarly, when we are talking about peat, when it is highly organic and the soil contains organic and decomposed vegetation, in that case it will be classified as peat. We will be discussing later on that for peat there are no specific values given. So, we will be seeing on this thing that how peat is different from fine grained soil or coarse grained soil. So, let us see here, it is given, we will be basically considering this 75 micron IS sieve. Anything above this thing means if anything is retained on this sieve, like let us say there is 100 grams of soil that you have taken. Now, let us say that when we place this heap of soil on which contains granular particles, different particles, and let us say that 70 grams is retained on this 75 micron sieve and 30 grams that passes on. Some soil will be retained because it is greater than 75 micron IS sieve, and some part will be passing on, that is will be 30 grams. So, understand this thing that this 70 gram, it is what? It is more than 50% of what? 100 grams, that is the total soil. It is more than what? 100 grams. So, in this thing remember here that this is more than 50%, that is what we are talking. When 50% or more of the soil is retained on 75 micron IS sieve, it will be classified as coarse grained soil. So, the soil we have taken here, this is what? This is coarse grained soil. Similarly, if in another case we are taking that 100 gram soil and another same sieve 75 micron IS sieve, Indian standard sieve, and if let us say 15 gram of soil is retained here and rest 85 grams passed down. So, we know that a very fine fraction, finer than what? Finer than 75 microns is being passed on, from the 75 micron IS sieve. So, we will be knowing that this is a fine grained soil, and we will be looking on further by these examples, certain examples. So, the first thing we will be classifying what is a coarse grained soil, what is a fine grained soil. We will be looking on these things. First, the very first topic we will be studying here, the coarse grained soil. So, I have said that some percentage retains on 75 micron IS sieve, but is that gravel or is that sand? As we all know that the size of gravel is greater than of sand, you all know this thing. But when we are talking about 75 micron IS sieve, can you tell me which is the when we are taking that something is retained on 75 micron IS sieve, so can you tell me which one is gravel or which one is sand? No. Why? Because we do not know that whether it is greater than 4.75 mm IS sieve or it is less than 4.75 mm IS sieve and greater than 75 micron IS sieve. So, we do not have the actual classification. So, here coarse grained soil is subdivided, we will be subdividing that coarse grained, and when we go on to the fine grained section, we will be seeing how that thing is also subdivided into smaller particles. One thing more, as we have studied in particle sizes, how in the sieve analysis also, and various other things, that there is cobble and there is boulder also. Boulder, it is greater than 300 mm size, and cobble it is between 80 and 300 mm. So, we are not considering those soils, I am telling you this thing from the start, that we are not considering those soils, and we will be considering only the gravel and sand when we are talking about the coarse grained fraction. When we will be talking about the fine grained soil, we will be taking what? Clay and silt. So, see here, the coarse grained soil is subdivided into gravel when more than 50% of coarse fraction. See here, important thing is 50% of what? Coarse fraction. That is, when I give you the example here, it is like 100 grams and let us say 80 grams is retained here. If 80 grams is retained, so understand this thing that the major fraction is coarse grained. So, we have said this is more than 50% of what? This 100, but when we talk about this gravel, we will be considering this 80 grams, and we will be talking about this 80 grams only, not the 20 gram which has passed through. So, whatever is retained, 50% of the coarse fraction is retained on 4.75 mm IS sieve, and sand if more than 50% of coarse fraction is smaller than 4.75 mm IS sieve. So, let us say here there is one soil, one sieve 4.75 mm IS sieve, and there is another sieve that is 75 microns. Now, see here that in this 4.75 and 75 micron, this anything above this is coarse fraction. So, now we are classifying it into either it is gravel or either it is sand. So, if we are taking this soil, if something is retained here, so it will be what? It will be classified as gravel, and if something is retained on here and the soil passes here through this 4.75 mm IS sieve, so it will be classified as sand. So, basically we are now subdividing it, and it is being classified into 4.75 mm and 75 micron sieve. So, anything between 4.75 mm and 75 micron will be what? Sand particles. And if we are considering this 80 grams that we have taken up here, 80 grams, so this 80 grams we will be considering this. If let us say 45 gram is retained here, if 45 gram is retained here, so more than 50% of this thing, this 80 grams, that is more than 40 grams soil is being retained. So, the soil will be what? Gravel. And if let us say 20 gram would have been retained on 4.75 mm sieve and the rest passes down. So, 20 gram is what? Very much less than the 50% of 80 grams, that is less than 40 grams. So, the soil will be classified as sand. Now, we will be saying that if the soil is coarse grained, but it may contain what? It may contain some fines. So, if there are fines, we will be seeing three cases. If fineness is less than 5%, if percentage fineness is greater than 12%, and the third case we will be studying, that is if percentage fineness is between 5% and 12%. So, these are three cases. If percentage fineness is less than 5%, we will be totally ignoring the fines, we will be neglecting the fines, and we will be considering the entire soil as gravel and sand, and we will be look upon the gradation characteristics. What are the gradation characteristics here? It can be well graded or it can be poorly graded. So, now let us begin with this thing. How can you classify that this soil is coarse graded or? So, in this case, a soil, when we know that the much of the soil fraction is gravel or much of the soil fraction is sand, so we will be classifying it into what? Either it will be well graded or it will be poorly graded. So, it will be GP and it will be GW. G is what? We studied it in, it is prefix, and W is what? It is the suffix which we have already discussed in the previous table. This G is again gravel, and then this P is poorly graded gravel. So, there are certain conditions which we will be seeing. Similarly, if we found out that it is sand, if the major proportion is sand, so it can also be what? It can also be well graded sand or poorly graded sand. So, what are the conditions which need to be satisfied for this SW and SP? So, see here, when we are talking about GW or SW, so if they are well graded, so here coefficient of uniformity should be greater than 4 and CC should be belonging to 1 and 3, that is coefficient of curvature should be between 1 and 3. Similarly, if you are talking about sand, here the coefficient of uniformity should be greater than 6 and the coefficient of curvature should belong to 1 and 3, these two values. If these two conditions are not satisfied, I am again repeating this thing, because both, when we are taking these conditions, we are taking both the conditions together. Even if one condition gets satisfied, it does not matter, both the conditions have to be satisfied, because if both the conditions are satisfied, then it is classified as a well graded one, and if it is not satisfied, it will be classified as poorly graded gravel or poorly graded sand, according to how we have divided into coarse or gravel or sand. Now we are moving on to the second case. If percentage fineness is greater than 12%. So what we are saying, that there is some coarse grained soil, that is 0.075 mm, and some part, major portion, let us say 100 gram, if we take the soil 100 gram, and then major portion is retained here, let us say 80%, or then the percentage fine is what, 20 gram, that is 20%. So understand one thing here, percentage fineness, that is greater than this 21 is this 20%, this 20 grams here, either we say it in grams or in fraction. So what is this? This is more than 12%, this is more than 12%, and now we will be considering here, in the very first case we did not consider anything, we were considering only GW and GP or SW or SP. Now in the second case we will be considering what, see here, it is GM or SM, then C and then clay, then again M, this one M and then C. What do these suffixes denote? That the soil which is majorly gravel or sand, that is a coarse grained fraction, also contains what? Also contains the fines. Fines can be what? Silt or clay. When you are talking about fines, you will be considering two things. What? One is the silt, another is the clay. These two things we will be considering here. So let us say if the soil contains more of what? Silt. So it will be classified as GM, that is a gravelly soil which contains more of silt, it will be classified as GM. Similarly, if it is GC, because this soil has been classified as GC because it has gravel, major portion is gravel, the coarse fraction, and also the fines which is like, let us say here 20% or 20 grams, it will be what? It is clay. If the major portion of this 20 is clay, so we will be classifying it as GC. Similarly, if the soil is sand, so and having a major portion of fines as silt, it will be classified as SM, and major portion of this sand is clay in terms of fines, it will be classified as SC. And if both are present, then that is GM and GC, that is or SM or SC, that denotes that gravel, this one GM GC, this will be denoted what? This will be denoting that the gravel contains what? M, that is silt, and C, that is clay, both the things. Similarly, SM and SC. So moving on to the next part, that if percentage fineness is between 5 and 12%, then dual representation of soil is done, because in the very first point we neglected something. In the very second part we were discussing about what is the nature of the fines, but when we are doing this between 5 and 12%, it will be discussing, we will be discussing here what? The gradation in the very first part and the nature of fines in the very second part. So let us see here GW GM, the very first thing, GW GM. So the very first part is denoting what? It is a gravelly soil, we can all see this gravel, this one G gravel, and when you are talking about this W, it is what? Showing well graded soil. So this is denoting what? The gradation. And this M is what? The gravel contains what? Gravel contains the silt particles. So this will be classified as the GM. So we have incorporated both the things. We have taken the less than 5% part, that was telling the gradation only, and greater than 12% part, that was telling what? That was telling the fineness. What is the nature of fines? How much particles are there in that portion. So here GM will denote what? The nature of fines. Similarly, if we take this case SWSC, so it is a well graded sand, we have already classified as it sand after the sieve analysis. Then what kind of fines are present, it will be denoted by SC, sand which contains what? Clay. So these are this. Similarly, GWGC, a gravelly soil which is well graded and has nature of fines is between that is more silt is less than clay portion. So it will be denoted as GC. If we take GPGM, so it is poorly graded soil first of all, and second thing, remember this thing that when we are talking about GM, so this M denotes that M is greater than C, the percentage of silt is greater than what? Greater than clay. Similarly, GPGC, when we are discussing this thing, it is what? Poorly graded gravel, and this GC will denote that clay is greater than silt. The nature of fines is there, the fines are there, the fines are when you are talking about 75 micron passing, then the fines are there, but at what percentage? They are between 5 and 12%. Let us say this is 75 micron IS sieve. Remember this thing, this is 75 micron IS sieve, and we say it is, let us say 92% is retained here and 8% passage. So this is the percentage fine, and this falls into what category? This third category. Percentage fineness is between 5 and 12%. So this thing here we will be classifying it a dual symbol, and in other cases we have seen that how we have classified into different things. Here also see SWSM, it is a well graded sand, but it contains what? It contains silt as fines, that is M is greater than what? Clay. Similarly, SPSM, poorly graded sand, the very first part denoting the gradation and the second part denoting the nature of fines. So we know that M, that means M is greater than C, that is the in this 8%, let us say this 8%, same taking the same example 8%, in this 8% more portion is of silt, and lesser portion is of clay. So you have to see what proportion. First of all, we will be classifying the soil into coarse grained soil, and the second one, and the very second one, we will be sub classifying it into what? Into gravel or sand, and then after that we will be seeing if that gravel contains more number of fines. If the fines is more, so what we will be seeing? If the fines is more, we will be seeing the different cases that we have seen here. So let us say it is coarse, it is gravel, it is sand. So one classification was that is it well graded or it is poorly graded. Similarly, sand, it is well graded or poorly graded. And if we take about the nature of fines, we will be taking that if more fines are there, then at that time we will be seeing what is the nature of fines, that is either it is silt or clay which is present in the that soil, the gravel or sand. So for this classification is here, this point is that we will be classifying these different types of soil, and in the next topic we will be discussing how the fine grained soil are being classified. Okay. So we will be meeting in the next class, and we will be discussing and continuing the same topic. Thank you.